Hi, my name is Miro Petrovec, coming from Ljubljana, Slovenia, and I propose that we start already the meeting. We are a little bit late, so not to be too late on the end. Thank you first of all for inviting me to give you a speech and a little bit of our experience, how we actually use our microbiological knowledge to actually accomplish some other things also than the work we did already. So I'm coming from the Institute of Microbiology, which is part of University of Ljubljana, part of Faculty of Medicine. We are biggest institute of the whole faculty, and we have around 180 employees who work on 3 different areas, which are teaching, research, and also we call it routine work or professional work in diagnostics. Inside our facilities, we have BSL-free laboratory capacity. We are the first one for about 25 years when we start to persuade our political people who make decisions to let us build BSL-free laboratory, which in turn we would like to use not only for research, but also for professional activities, and also maybe from some other things which I'll show you later in my talk. So we have enough experienced personnel, and even before the BSL-3, we are working in development and evaluation of diagnostics assay for potential bioagent and intervention plan. Training of first responders in a case of an outbreak and unusual events of major natural disaster. So in a couple of years, we are able to actually build a small BSL-free laboratory, which is, as I told you, used for research and also for the routine work. So we are then moving closer to the forensic microbiology and the field of bioterrorism. You probably remember how it started all with the white powder in the United States. And you know the definition of bioterrorism, which is actually involving the intentional release or dissemination of biological agents, being bacteria, viruses, fungi, or toxins of their origin. So in 2005 in Slovenia, it developed the National Emergency Response Plan in the case of a terrorist attack, which actually it's, in my view, quite smartly made and involve all possible parties in Slovenia. So different institutes, not only the state-owned, but really the public institutes who has expertise in toxins, chemical, and all other potential bioterroristic agents, or also the support system, which is like a surveillance of civil aeronautics and so on. But in our case, it was very important that our national agency for civil protection, which is under the Ministry of Defense, recognized the university and the institute as a partner in developing a response plan offering infrastructure and personal capacity for diagnosis of potential bioterroristic agents. So the plan was made, and it's now actually in place as it is shown here. So if something is happened, then we have like in United States 911, in Slovenia probably this is European one, is 112 or 113, and this is then alarming fire brigades or special police force, emergency first aid team, and laboratory for intervention, which encompass our lab from medical faculty and veterinary faculty. If needed, the other institutions are involved, and then communicating with the public. So how it happens actually, here is a National Information Center, they have a leader of intervention team, they assign it immediately. There is deputy intervention leader, and head of the institute should be also immediately notified. We have 24 hours, 7 days a week, so whole year, 24 hours people in preparation. So we can actually start with intervention inside 30 minutes. To alleviate a little bit of this burden, we share this with another group which is based in the Faculty of Veterinary Medicine in Ljubljana. So all phone contacts and also some wireless other contacts are available. So what is happening if it's coming for the emergency, we activate diagnostic procedure, which is based on a quick three-step testing. First one is quick test system, which is usually accomplished in about an hour. Then molecular methods, which are specific or universal, and cultivation classical method. The one which used mainly is biofire defense, fully integrated suite for identification of biological agent, and in between, in every intervention, there is a real-time communication with all involved parties. So what are the initial steps? So we need to recognize the unusual event, which is usually happening, like finding an envelope with the white powder, being in you would see the institution where we intervene from parliament to presidential office to post office and all kind of places. So then we need rapid identification of microbial agent. So we need to cope with the panic in public, so we communicate also with this information center, and then they made effective communication with the media. So how is our teams equipped? We have 3 specialists that are capable of molecular and classical virological bacterial laboratory. We have 1 team leader, then 3 medical specialists, and also then we have 5 specialists for molecular microbiology, and the technicians which have several years of experience. So this is real pictures. It is not something from the internet, how it works. This is the entrance of Slovenian parliament. And what is our goal is actually to come to the site of contamination and actually go inside and do the sampling, then do the packaging, then assessing the situation, also provide technical guidance. Because it's very important to sample correctly into the sterile envelopes, and also not to contaminate it on the site itself. And also, you can imagine they're in very different packaging, all these threatening materials. So this is how they collect. They need to disinfect the team when it comes out, and then start with the bacteriological investigation. This is the real-time, real pictures again, what we do. Usually it's white powder, you see here, sent to different kind of, okay, we see this. So this is a film array, which I told you, it has about 25 target genes for biological agents, from anthrax to tularemia to all hemorrhagic fever viruses, orthopox viruses, and so on. But beside that, we also develop our own molecular assays, which are validated. We participate in external control, also performing universal bacterial PCR. So if there would be maybe something modified, we can still catch it later on in a couple of hours during an intervention. And not to forget, we also use the classical bacteriological methods, but inside the P3 lab, just to be sure that we won't miss anything or jeopardize. You can see here a couple of numbers. They are not updated with, let's say, COVID season, but you can see here like 35 intervention per year. It's almost like every other week we have to deal with these threatening letters, which is really, how to say, very demanding. And here are written the locations where we have interventions. You see the government and ministries, most often the targets, then the post office, public institutions, private companies also, local politicians like mayors of the cities. They, especially before some elections, they used to get these threatening letters with white powder. And also courts are quite often targets to actually not working. So let me show you one very interesting case, which is which I was also involved. It happening in October in 2018. We got the call from emergency dispatch center that the cleaning lady found a strange virus with the variola sign on the bottles. This is a hotel resort. It's actually about, I think, 500 meters from Italian border in Nova Gorica. It was very funny that actually cleaning lady found the box and was actually attentive to what is written on the box. So based on the description, the police is packing the found material, and they were transported to the lab. And what we found here is something which I'm not speaker of Italian, but was to me very clear that it's originating in Italy. It is vaccino antivaioloso, and it's from Instituto Sieroterapico Milanese. We Googled it immediately, and we realized that this is long time gone institution, but still you have a vials with some materials inside. So we are thinking that this is probably really a vaccine for the smallpox, actually vaccinia. So what was also very strange is that actually the people who left this in the room come with the forged documents and they disappear. So nobody knows actually who and for what reason is leaving this in the hotel room. So the box contains 9 ampoules wrapped in the cotton wool, and were of diverse sizes, you see, with closed cork caps. Inside was seen like dried black powder, which some places were aggregated, and we rehydrated 6 from these 9 ampoules with the phosphate buffer saline, and then performed DNA isolation and film array. And the results is showing that we actually dealing with some orthopox virus, but it's not variola. So that was even on the, after an hour we get this, and then we make additional assays. We get the signal for orthopox viruses, but no actually information about pox virus species. So we could not tell which kind of pox virus is present in this. So we want to understand why all classical PCRs are actually failing, not showing what we have. And with, we perform DNA quality control and find that actually, sure, for after all these years, DNA is fragmented and DNA concentration was less than 2.0 nanogram per microliter. Actually, this is what can we Google it about the institute which producing this vaccine. Actually was very old one and was the first vaccine manufactured in Italy, and in 1991 actually stopped with existence. So we could not actually get any more information. So what can we do? We actually, what we know, we inform the public health and actually tell them that this is actually traces of orthopox virus nucleic acids and there is no risk for infection, which was actually most needed. But, you know, as a microbiologist, we still would like to know what is inside this vials. So not to bother you with this, You know about the vaccine against the orthopox virus. Usually there is a mixture. Nobody know actually what was actually which kind of virus it is. Could be a cowpox or horsepox or maybe even something else. So whatever it was actually over time passed through many different animals, and we don't know actually what is inside. So we use NGS technology, and we try to find a little bit something, and actually we get signals mostly connected to the horsepox actually virus. So this is still don't know why they are leaving these bottles behind. Really was a little bit frightening. Also because of these forged documents, we could not trace the people. Nobody could actually know who and for what reason is living there. So for the end, I would just like to show how we share our expertise to actually establish our biological military unit. And actually we were really a good collaborator to establish Army Mobile Laboratory for Biological, Chemical, and Radiological Threats based inside container, which is deployable. It weighs about 10 tons and have a BSL-free facility. We also train their microbiologists, also the decontamination team, and also mostly our role is to building diagnostic capacity, identification with real-time PCR, also helping him to start working with the glow box and do proper decontamination. This is how it looks. Inside, I think the mostly was done, almost all the equipment is done in Slovenia. They have a special also place to pass through the chamber the materials inside this, and you see here they have this quite well developed microbiological opportunity for molecular diagnostics. We have regular exercises, which is called FALCO. Probably it's every year, maybe it was not that active during the COVID, but still it's very important that we give them support, and we are also officially named as a reference lab. So if they found something, they would pass it through us afterwards for confirmation. This is some pictures from the exercises, which I think it's well received and well perceived also by the public. And the main message is actually, if you have expertise for some professional work, it's very good to share it with other instances, and being really also very rational. So it's no need for very big investments, but still you can be self-sufficient. Slovenia is a very small country, and we still manage it to actually train enough people to do the task of answering to biothreats. So thank you a lot, and if there are any questions, I would be happy to answer it. Thank you.
Thank you very much for your very wonderful presentation. Me as microbiologist, I'm impressed by your facility and capacity to do. My question is regarding the mobile facility. The maintenance for it, because if you don't use it daily, and you don't use it as a daily work, who pays the maintenance and how much it takes?
Very good question. Actually, for BSL free, it was like 80% or 70% financed by the research ministry. I mean, the not mobile one, it's the fixed one. But for the mobile one, we immediately say this is not in our capacity, just for the reasons you mentioned, that we could not maintain the mobile unit. which actually it's better to be suited with the army, because the army could deploy it, the army have their own budget to keep it going. And I know that they were active also with some missions abroad also. They were deployed for a couple of months, so they put it into use. So, but for our preparedness, which also costs some money, we, with the years, with constant persuasion, actually get a budget. I think that I'm correct that we come from like 5,000 euro per year to 35,000 euro per year, and they pay all the preparedness for the staff, which actually is available 24 hours. They are our employees, but we have a contract with the Ministry of Defense. They are the final one who pay for this group. But this is not the group who work in the mobile lab. The mobile lab is completely, strictly under the Army command. So we are just, also we have with the special contract to help them doing this reference and confirmation work. This is really very low budget, but for us it's very important because you need to cover, even if it's not significant expenses, it needs to be covered. But with the civil protection, it really develops every year. They every year raise the budget, which is on the state level really low. They also give us now the proper car to transport the samples with really a nice one, which civil protection is also used. And they, I told you also for the Faculty of Veterinary Medicine, they equip us every year a little bit more with equipment and support it in that way. And I think that it's really still a lot cheaper if you go other way and work with the special unit, as Mariana said, which would actually have very few interventions during the year. Yes.
Where do you think that human resources offer this benefit?
It is very hard. For human resources, it's very hard. So these exercise, I think, exercises are going for 3 to 4 days. And you ask for preparation of material. We are preparing the strains. Usually that is what we are doing. So they are blinded to what they would need to determine. So we are careful not to use, let's say, really pathogenic or dangerous stuff. So we use some modified microorganisms. So they give them to identify. But yes, when there is exercise, usually like 3/4 of the lab who is doing this is outside, but they like it. They fly them with a helicopter sometimes, and they enjoy it a lot. The exercises are paid, I think, separately from the Ministry of Defense again. Yes, yes, it is important, but I really would like, I mean, the point of my talk is, because this was not happening overnight, we are really persuading them many years that this is best solution for a small country with a small budget to do it. Because if you just make a separate unit, you know, it's like firefighters. If there is no fire, there is no work except exercises. But that's good. Okay. For the first question, I am really not sure what is the real sensitivity, because there are, you know, like 15 targets and they have absolutely true different kind of sensitivities. It is very sensitive, I can tell you, because it's PCR based, but I could not give you exact number, but I can check it and get it back to you. But regarding the second question, we are immediately, after we get this first report, we contact immediately the leader of intervention about the first test, and usually the firefighters, which are also the first responders, also use some quick tests, which are not molecularly based. And we immediately started, at the same time we start the quick tests, we start our own PCRs. So usually it takes about 4 hours that we provide official report, stamped and written by the intervention leader from our side. And the final results is usually produced 24 hours after we receive the samples, also checking for any growth in the media, and that is usually how it happened. But we are really looking for these 4 hours, because in Slovenia they're very strict. They put people in quarantine, they lock them down, doesn't matter if president or major, they are locked down at the place where they found this, and or maybe employees at the post, we've been called at 3 at night, they lock them down and they don't let move anyone out before they get results. Okay, thank you. Let's move to the next presentation, which will be provided with Professor Adrian Bailey. He's with us with the presentation Pain Research as an Example of the Evolution of Biomedical Science, State Support with a Normative Framework.
Thank you a lot for your kind presentation. Pain research is my field of interest. But today I will present an historical perspective on what biotechnology and biomedical science is an important issue, especially in contemporary context. So to be more explicit and faster, I will pass to Romanian with your permission, but slides are in English. Deci, această prezentare nu este despre fiziologia nocicepției și percepției durerii, dar să vedem cum a evoluat știința și tehnologia științei și de ce aceasta nu mai poate evolua astăzi dacă noi menținem aceleași condiții de care noi dispunem în ziua de astăzi. Adică trebuie să evolueze și aceste condiții. Toți cunoaștem teoriile clasice și în special în durere este teoria lui Descartes, care pentru prima dată a delimitat segmentul de recepție, transmitere și formare a percepției. Această structură clasică a analizatorilor este valabilă și în prezent. Paralel s-au dezvoltat două teorii în baza școlilor la care au lucrat fondatorii școlilor respective. Aceasta este teoria specificității, deoarece acei cercetători descopereau fibre nervoase noi, căi neuronale noi, noi receptori și atunci spuneau că formarea percepției dureroase și transmiterea impulsului nociceptiv depinde de o structură specifică. Ceilalți care erau bazați pe fiziologie descopereau că și alte tipuri de receptori și alte tipuri de fibre nervoase se activează dacă trece stimularea de un anumit prag. Și ei țineau de această ipoteză și aceste două școli mergeau paralel. Competiția acestor două elemente a durat foarte mult. Vedeți, mai mult de jumătate de secol, intrând mult în epoca modernă, până când Paul Nafe a dorit să le îmbine într-un mod și să le explice, enunțând teoria codificării semnalului și a spus că nu contează că este un receptor specific sau un receptor nespecific, dar dacă semnalul are un anumit tipar codificat în timp și spațiu, atunci, prin decodificarea acestui semnal, se formează o percepție anumită, în caz dat, percepția dureroasă. Până la urmă, din punctul de vedere contemporan, nici acest fapt nu este adevărat până la capăt, dar el reprezintă un element al puzzle-ului care conține un adevăr și acest adevăr va fi utilizat în cu totul alt context. Teoria porții de control este teoria clasică care noi am învățat-o, da? Iarăși bazată pe o structură funcțională neuronală al cornului medular dorsal, cu toate că interacțiunile sinaptice și diversitatea biochimică este extrem de complicată. S-a oferit premiul Nobel pentru această teorie, dar iarăși aceste descoperiri se făceau în laboratoare clasice și de unde se răspândeau în toată lumea. Abordarea contemporană are puțin altă abordare. Începem cu partea clasică, deja devenită, teoria neuromatrixului în durere, în care, dacă o luăm să o explicăm, există partea hard, materială, și în special homunculusul senzorial și cel motor. Corpul nostru arată așa din punct de vedere senzorial și arată așa din punct de vedere motor, cu toate că noi în oglindă, când ne privim, ne vedem așa cum ne cunoaștem. Și pe acest hard se derulează un soft care ne va forma conștiința. Elementele de activitate se pot observa și următoarea etapă este demonstrarea practică a existenței acestei teorii a neuromatrixului, care, în cazul durerii, a identificat numeroase focare, adică nu există un centru special al durerii, dar un sistem funcțional care este foarte diferit în funcție de context, de personalitatea omului care suferă de această durere. Și aici vedem diferite elemente. Elementul de anticipare a durerii, adică omul știe că îl va durea peste un anumit timp și deja apare un focar de activitate cerebrală peste care se va suprapune durerea reală. Aici vedem percepția clară a durerii, elementul ei de intensitate și vedeți zonele motorii și senzoriale de pe homunculus cum sunt activate și plus zonele de reacție clasică din amigdală. Și ceea ce este foarte variabil și foarte consumator de energie și ceea ce epuizează pacienții este componentul afectiv și emoțional al durerii, care ține foarte mult de comunicarea dintre medic și pacient sau dintre medic și anturajul lui. În principiu vedem că există anumite, spunem, focare care se aprind și vedem o activitate cerebrală, un sistem funcțional care lucrează, dar totodată este foarte interesant să aflăm cum este conectat o structură cerebrală cu altă structură cerebrală. Ideea este că activitatea reală o poți vedea doar atunci când organismul este viu și nu poți diseca ceva să observe acest lucru, da? Pe un cadavru sau un organ preparat. Este nevoie de o persoană vie sau de un animal viu. Și asta, tehnologia a permis dezvoltarea tractografiei și această tehnologie a permis identificarea și urmărirea conexiunilor cerebrale individuale de la an, din ce în ce mai detaliat, și această idee și acest proiect a devenit un proiect transnațional, care se numește Human Connectome Project. Îl scrieți în Google, vedeți cu ce se ocupă și se dau detaliile acestor conexiuni, fie pe patologie, fie pe circumstanțe, fie pe fel de alte elemente de care lucrează laboratorul concret, dar toate vin într-o bază de date unică. Alt element este densitatea sinaptică și interacțiunea dintre astrociți și neuroni, și cât n-ar părea de interesant și paradoxal, densitatea neuronală, formarea personalității noastre, dispoziția, modul de a gândi, dar și percepția durerii, este determinată, straniu, conexiunea cu microbiologia, de microbiomul uman. Deoarece bacteriile din interiorul nostru ne determină comportamentul, stilul de viață și adaptabilitatea la mediul extern mai mult decât noi ne-am închipuit. Și ele determină direct densitatea sinaptică și capacitatea noastră cognitivă foarte, foarte mult, inclusiv în perioada intrauterină. Deci, cât n-ar părea de straniu, studiul asupra durerii s-a conectat prin această cale cu studiile în microbiologie, direct legate cu biotehnologia. Ce este interesant, plasticitatea neuronală care va crea acele premize de evoluție a personalității noastre. Adică creierul ne va oferi atâta spațiu fizic și atâta dezvoltare în percepție, în direcția în care noi gândim sau în direcția în care noi acționăm. Aici observăm un experiment în care o persoană este învățată să cânte la vioară. Cu cât se învață mai mult să cânte la vioară, cu atât spațiul fizic și complexitatea algoritmică a cântatului la vioară este identificată prin această imagine de imagerie funcțională. Care este consecința practică a acestui studiu? Are un impact foarte și foarte direct în viața noastră cotidiană. Dacă noi gândim rău, pesimist, că totul e rău, da? Nici o problemă, întreg creierul va acționa neuroplasticitatea, ne va oferi spațiu fizic și o complexitate algoritmică mai bună, că noi să putem gândi încă mai pesimist, încă mai rău, că lucrurile se întâmplă încă mai rău. Și invers, dacă noi vom gândi pozitiv, lucrurile se vor întâmpla exact invers. Și nu este o supoziție, dar, vedeți, este o dovadă neurofiziologică deja certificată și este cu impact direct la ceea ce gândim noi în ziua de astăzi. Da? Nu este sfârșitul lumii, gândind pozitiv, totul va fi bine. Mai departe, da? Conștiința noastră, cât n-ar părea de straniu, dar ea este virtuală, ea este plasată pe hardul nostru material și ea este determinată de un eu, care este absolut virtual, și pe acest eu se derulează alte elemente de percepție. De exemplu, neuromărcile, da? Pentru a percepe auzul, nouă ne trebuie un decoder pentru sunete, neuromarca auzului, neuromarca culorilor, neuromarci pentru orice, vreo 50.000 de neuromarci. Decodificarea lor ne permite să interpretăm semnalele biologice la cu totul un alt nivel, să le prognozăm și să le imităm. De exemplu, vedeți imaginile comerciale de aparate acționate mental, de exemplu, da? Sau monitorul utilizat în decodificarea traficului nociceptiv intraoperator, 30 de ani de lucru pentru decodificarea dată. Neuralink-ul, da? Un alt mare proiect al lui Elon Musk care permite integrarea și imitarea mișcării, vederii și analgeziei cu o mare perspectivă în terapie, unde o microneurochirurgie robotizată va integra biologia cu tehnologie pentru a da o șansă multor alți oameni la o calitate bună a vieții. Noi am vorbit astăzi acum în sistemele macro, ce țin de tehnologiile informaționale, de complexitate algoritmică, de inteligență artificială, în sensul invers, în sens micro. Dacă ne uităm, înainte știința studia nivelul macroscopic, după care a trecut la nivelul microscopic, nivelul nano, da, când se identificau receptori speciali sau specifici, biochimici, și ultima etapă este scala pico, în care deja observăm că se cunoaște structura tridimensională și consecutivitatea aminoacizelor, proteinelor și traducerea lor în ADN și în RNA. Există un mare proiect internațional, o bază de date, în care fiecare laborator concentrează într-un singur loc secvența ADN și RNA a tuturor proteinelor cunoscute de pe Terra și secvența lor aminoacidică pe de altă parte. Deci, aici este un receptor protonic care reprezintă următoarea țintă de control a durerii în sens farmacologic, deoarece blocarea lui calmează aproape orice tip de durere, fie acută, fie cronică. Această biotehnologie permite, de exemplu, identificarea și construirea tridimensională a moleculelor și noi vedem aici vederea de deasupra a canalului de caliu, da? Cu molecula de caliu exact pe mijloc aici, dar asta este întreg canalul văzut deasupra. Însă există o mare variabilitate a canalelor de caliu în lume și între persoane. Da? Cum se vede această variabilitate? Prin interacțiunea veninurilor de animale cu canalul de caliu, deoarece este cel mai potrivit ligand pentru ele. În acest mod au fost descoperite și derulate secvențe numeroase la fel de subvariante a canalelor de caliu și este o bază de date dedicată anume lui. Deci, iarăși, vedem o colaborare internațională, o bază de date, o informatizare a proceselor. Deci, apar, în sensul dat, noi științe, știința de epigenetică, da? Când s-a observat că alimentarea pupelor de albină va determina evoluția lor în albină lucrătoare, în trântor sau în matcă, care determină prin alimentare o activare sau o dezactivare genetică, mecanism descoperit în 2007, ceea ce înseamnă că, observați și aici, în această afirmație, jos, da, aici, că chiar dacă gândim pozitiv, da, fumăm sau ceea ce mâncăm, va acționa materialul nostru genetic și ne va determina soarta mai departe. Adică dacă noi plângem azi și plângem în continuu, să plângem încă 300 de ani înainte, până noi să ne schimbăm abordarea față de viață și schimbarea mentalității. Este foarte, foarte important. De asemenea, am vorbit de bioinformatică și aici sunt exemple de biobănci și bănci de date în care ele sunt deschise, iar cercetătorii vor colabora în contribuirea la structuri noi sau la utilizarea bazelor de date existente pentru a le utiliza mai departe în cercetările lor, în terapia durerii, serie de molecule, în orice alt domeniu, fix același principiu de abordare. De aici pornește și medicina translațională, că odată ce s-a descoperit o nouă structură și un nou medicament, el poate fi modelat și transpus repede în practică. Am văzut asta foarte bine și foarte frumos în COVID, la elaborarea antiviralelor, la construirea genealogiei virusului, cu monitorizarea mutațiilor și la elaborarea vaccinurilor. Este un exemplu clasic de medicină translațională, cu toate limitele ei actuale, dar este iarăși o nouă direcție în medicină și în durere de asemenea. Medicina translațională permite îndreptarea și orientarea spre medicina personalizată, în care, cunoscând deja baza de date sau mai bine zis, variabilitatea individuală genetică, da, și identificând persoana dintr-un nor de date, va putea fi conectată genetica individuală, predispoziția individuală la boală și răspunsul individual la tratament. De exemplu, în ziua de astăzi, cel mai simplu exemplu, până la 15% din populație este rezistentă la tratamentul cu aspirină. Da? Până la 5% din populație este rezistentă la tratamentul cu clopidogrel. Deci, care este proporția acestei populații în Republica Moldova nu este cunoscut, deci avem nevoie de studii genetice populaționale pentru a vedea dacă politicile de sănătate cu privire la profilaxia maladiilor cardiovasculare este bine pusă la punct și medicamentele alese sunt bune. Sau în terapia durerii, de exemplu, da? Anumite antiinflamatoare non-steroide vor fi mai eficiente pe un grup de populație și mai puțin eficiente pe alte grupuri de populație. Deci, medicina translațională are anumite provocări, deoarece există mai multe ipoteze științifice decât pacienți pentru probarea lor. Cercetarea are prețuri astronomice, e evident că există și barierele de reglementare sau a principiilor etice, dar totuși, anume prin cooperare și prin punerea în comun a cunoștințelor, se poate încet depăși aceste limite. Deci, bioinformatica ca un mănunchi de noi cunoștințe, transcriptomica, proteomica, interactomica, metabolomica, metagenomica și metaproteomica, da, nu le mai descifrez pe toate, dar reprezintă noțiuni noi care omul de știință contemporan trebuie să le ia la înarmare. Este o scară pico, da? Dar asta este baza tehnologiei și biotehnologiei de care noi vorbim astăzi și care acest mare proiect pe care îl inițiază Universitatea vine să includă și Moldova în acest circuit. Deci, bun, unde este statul în tot acest context? Da? Și care este rolul statului? Bine, să luăm o serie de cuvinte cheie care noi am văzut-o la partea asta de știință care am expus-o, da? Transcriptomică, proteomică și așa mai departe, medicină translațională, big data, inteligență artificială. Ok, care este rolul statului? Statul tot se definește prin anumite cuvinte cheie care oferă niște condiții și niște oportunități. Independență, democrație, libertate, pace, statul de drept, educație, cooperare, infrastructură, sănătate, globalizare, dezvoltare și așa mai departe. Deci, ceea ce am vorbit eu de dimineață, proiectul de generație al țării noastre este mișcarea spre Uniunea Europeană. Orice cuvânt cheie de aici este o mică contribuție a fiecărui din noi. Stând cu pachetul de popcorn în mână, noi nu vom ajunge mai repede acolo unde ne-am pornit, lăsându-i pe cei aleși să-și facă treaba. Deci este foarte important, deoarece aceste cuvinte cheie este de datoria fiecăruia dintre noi pentru a pune bazele unui stat care să poată întreține acele cuvinte cheie din prima coloniță. Bine, asta e așa la modul general. La concret ce se propune anume în acest context. Deci, cadrul legal cel mai bine pentru a găsi o oportunitate de a implementa toate biotehnologiile. Biotehnologiile au nevoie de activitate biobancară, de servere pentru a ține informația, de reguli pentru a interacționa și a gestiona cu această informație, acreditarea și așa mai departe. Deci, Parlamentul în legislatura curentă și nemijlocit acum are în proces legislativ legea băncii biologice umane, în care se descriu principii de bază, principii de organizare, de funcționare, de evaluare, acreditare, a controlului calității, a drepturilor donatorilor de biospecimene, a consimțământului în formația normelor etice, a procesării biospecimenelor și principiul de gestionare cu datele asociate, evident că și aspectele financiare. Deci aceste reglementări transpun și directive europene pentru ca să fim compatibili și fac posibilă crearea de către Universitatea a unui biobănci de cercetare, de exemplu. Pentru Institutul Oncologic, de exemplu, creează premize pentru o biobancă aplicativă clinică. Pentru stat, crearea unei biobănci populaționale. Nu are importanță, privați sau publici, dar această lege pe care o dezvoltăm împreună cu colegii de la Universitate, care sunt și aici în sală, credem că din punctul de vedere al legislatorului, anume această intervenție oferă pentru domeniul biotehnologiei în Moldova oportunități și un cadru legal propice pentru dezvoltare. Deci, în ritm rapid, asta a fost prezentarea mea. Vă mulțumesc pentru atenție și gândiți pozitiv.
Thank you for your presentation.
Maybe we have a time for a short question. Or...
So, no questions.
And did you study the role of banks in pain?
The role of biological banks in pain?
The study about raw banks, they have not just anti-inflammatory situation, but also anti-nociceptive situation. And they now, just until now, only on mice cell recalls done, and they have very limited function in order to replace all the drugs, anti-pain drugs. And maybe we have some.
Okay, thank you. As I know, till today, there are known most of elementary biological structures in pain reception, transduction, and pain transmission. These are elementary biochemical receptors or ionic channels. And also there is a wide wide data bank or about individual selection of non-steroidal drugs, COX-1 or 2 inhibitors. Is a Canadian approach. After a questionnaire, they try to personalize this kind of drug selection, but more precise, I don't know yet, is a very specific issue, and also is far to our technological possibility to deal with. And we try to work at the level what we can manage today. But in any case, we have some connection with the persons who deal with this kind of research, and this exchange of information permit us to at least communicate the results to you. But could you come closer to us, because it's oh, okay. That's facem translational research. Come to us here. And,
thank you, Mr. Andrei, for your presentation. My name is Dorian. I'm a student at Lyceum, and as a collaboration between the USMF University and the USLA, the University from California, we had a collaboration between the Bioinformatics University from California and our university. And as a question, I've been introduced to bioinformatics from a professor from California, and I acquired some basic knowledge of what the bioinformatics means itself. And as a question for our implementation, how can I gain experience and apply for researches in my country? Because we have a very good country for doing researches in bioinformatics, but we don't have such human resources for doing these researches in particular.
Mm-hmm. So, thank you. So this is an issue for the next generation of researchers. I am very happy that you would like to continue in this field of research. Firstly, I think you should come to become a student of the University of Medicine or University of State University in Biological Faculty. And here I will show you after 2 or 3 persons who could you explain in detail how to deal with?
Yeah.
Because we have now structures and a good project at the beginning. But your knowledge is very, very useful to be used here in very near future.
Yeah. Thank you for your response.
I congratulate you, my dear student, Andrian. It's a good way to get private lessons. I am not sure I understood everything, and I apologize, I was in a meeting, but there is something that struck me. You said, from what you said, when I grew up in the Bible, it was written that if somebody had sin, there is a malediction for 7 generations. Then when I was a student, I learned that a gene after 7 generations have no chance to still exist. Mm-hmm. But now you told us with the epigenetics, if my grandparents were not making sport, I'm still suffering of that. So you are telling us the Bible is not right.
I'm not... I can't cite the Bible, but as I know, it told me a very old professor teaching young people that you should listen all of the professor say, but you should know that 50% of material is true and 50% of material is not true, and professor didn't know what part is true or not true. And here maybe there is a part of truth, a part of a lie, but I don't know where is the truth.
So we put that in a category of epi-truth. Thank you very much, Professor.
Thank you.
The next speaker is Dr. Luc Armand, General Secretary of the International Year of Basic Sciences for Sustainable Development from France. And he told me this morning that you can hear from his way of speaking English that he is really from France.
Yes, I am French.
So he's French and he is going to talk about 5 things to know to engage with the public.
Okay. So thank you so much for. I thank the two previous speakers, and I think it's the first time I listened to a member of parliament in activity. Speaking about science with such ease, and it was very interesting. And I hope there are some more in the parliament here, because it's really important that members of parliament know something about science. But I'm not here to give congratulations. I'm Luc Armand, as the presenter said. So I used to be a science journalist, and now I'm a science communication specialist. So I've been presented as the Secretary General of the International Year of Basic Sciences for Sustainable Development. And that's a teaser for tomorrow morning, because I will give you another talk about this specifically. But this afternoon, I will try to give you some interactive, I hope it will be interactive, short lesson about 5 things scientists should know about scientific outreach. So I said a few words about myself. I think that's enough. Now I would like to know a bit about you, but of course it would be a bit long to make a tour and to give the microphone to everybody, or to make them come here, because apparently other microphones don't work. So I will just ask you some questions, give some categories, and perhaps, well, you can raise your hand if you belong to the category, because I would like to know you a bit. So I suppose here we have some scientists in the room. So please, the scientists, can you raise your hands? Well, not much. I thought more. Okay, you can belong to different categories, don't worry. Are there science communicators? I've been told that perhaps there was some. Not just one, okay. Okay, I suppose there are no journalists. Yes, there's a journalist here, but she cannot raise her hand. Are there here people who don't know much about science? No, you're all familiar with science. And most probably there are students. Yeah, some. I don't know who the others are. All of you are professors, so the professor, can you raise your hands, all the professors we have here? Yeah, okay. So, well, I had some question about the kind of science you're doing, but as I understand, there are not much scientists here in the room, but perhaps even among the students and the professors and the other scientists, I guess there are a lot of biologists. No, yes, no, not, yeah, some perhaps a lot of medical doctors, as a matter of fact, because we're in a medical university. Yes, we have some medical doctors. Thank you. Some pharmacists, because yeah, 2, 3, yeah, okay. Thank you. Okay, and also there's a huge diversity in countries of origin. So, I think there are people from Moldova. Can you raise your hands? See, you're the majority, I hope. Okay, so there are some people from Romania. Oh, they're all gone. Okay, you can raise your hand twice. There's no problem. So there is a strong delegation from ICGEB. So there are people from Italy who come from Italy, and and among them, from what I heard, only one is really from Italy. Okay, and okay, so there are people from Slovenia? Yeah, so some, yeah, okay, thank you. And from Latvia, of course, we heard. We have 1, 2 here. From France, other than I? No, I'm the only one. Okay, and well, coming to my topic, does anybody has ever engaged in an outreach activity to try to reach the public? Yes, well, not much. And well, I would have asked some question about public conferences, etc., but that's it. It's not just to warm up the room. I'm doing this question. It's just because I wanted you to remind of my first point. So I try to push the button in the right way. So yes, my first point is just simply this: know your audience. When you want to engage in an outreach activity, you have to know who you are talking to, or at least to figure out who you want to talk to. Because you won't ever master who's in the room. Well, you're here, I have to adapt to you, to your knowledge, but that's why I try to understand who you are. And when you speak on the radio, and even if you're interviewed for TV, you don't know who will watch or listen, but at least you can think about who you want to reach. So that's very important. Of course, if you want to reach the general public, you won't use the same words, you won't tell the same stories. We'll come back on this later on. As if you want to reach scientists, for instance. If you're a scientist, you want to reach your colleagues, a bit like here. You know, you have students, you have professors, you have people who came here on purpose to learn about different parts of biotechnology, of research, of policy. And that's not the same as if you had the general public who was coming for a science week, or there in the near future there is the night or the researcher night or something like that. So remind this: you have to know your audience. Well, my second point, well, it will be a bit more difficult because I will have to ask you a question and you're supposed to give words to answer. So I don't know if it will work, but the second point is you have to know your purpose. So you have an audience, you know more or less who's there or who you want to reach, but why do you want to reach them? So perhaps, and you shout a bit if you answer, because there's no mobile microphone, but what can you say about why you would want to engage in an outreach activity? Go on, don't be shy. Yeah, share interesting information. I repeat for other, because perhaps everybody didn't hear. Yeah, share interesting information about the science to other people. Yes, that's a good reason. Other reasons?
Not only share the information, gain information in other side, and also, I mean, I'm a biobanker, so everyone here is a potential donor of a sample. So. Okay,
yeah. That's important. To mobilize people to help you in your research or to participate to the science. And we heard a lot about biobanks already today. Okay, other ideas? To reach specific groups? Could you give an example? Okay. Okay, that's a bit also of the same kind. Influence policymakers. We have one here. Most probably you are solicited by scientists to listen to what they're doing. Yes, that's also a good reason. Well, we could go on. I just give some other reasons. Perhaps you want to recruit children or students to do a science curriculum. So that's a good reason to share your results and to try to gain more students in science. Also, we heard this morning about pharma companies. Perhaps you share, sometimes you share your results or you share the science because you want to convince investors to give you some money to go on with your research. And perhaps a more ordinary reason, perhaps sometimes you have to explain your parents what you're doing for a living. Because they have to, well, they want to know. And that's, okay, and also sometimes some journalist comes and asks you, what are you doing? I need to understand. Okay, so there are many purposes. You could draw a list when back home, but you must remember this. Not only you have to know your audience, but also you have to have in mind why you want to engage them. Okay, so next, and I will have the help of my friend here of the technical. We had a rehearsal. So please, can you launch a video for 1 minute more or less?
You've likely heard about the effects that climate change is having on our planet, and specifically in the Arctic, which is warming twice as fast. But what would actually happen if all the ice melted on Earth?
I can help with that. When you and I drink water, we drink non-salty water, we drink fresh water. Now, all the water in the world, most of it is salty, just 3% is not salty. Now, that 3%, you can't get the most of that because 70% of that 3% is frozen. 30 million cubic kilometers of frozen water. It's so much frozen water, so much ice, that if you had a layer 1,000 meters thick, it would cover North America. That's a lot of frozen water, people.
Okay, you can stop, please.
Glaciers, ice sheets, permafrost.
Okay, thank you. No, don't go. Okay. No. Okay, I think I go back. Okay, I stay here. Do you know who is he? Bill Nye, okay. You know Bill Nye is a science guy. For those who don't know him, he's a TV presenter. He has presented a lot of science show in the US. And do you think, what do you think of what he said? Well, most probably you're not specialist of this topic, and I took it on purpose. Do you believe what he says? Who believes what he says? Raise your hand. Yeah. Who doesn't believe what he says? Okay, some are critical. Okay, you're always right to be critical. You know, when you talk about science, you're just like him. You're the science guy or the science girl or the science lady. Sorry for, but for people who don't know much about science, you are a scientist, so you should know. And that's why sometimes I ask you questions. And well, if I ask you, for instance, to explain, or I took some examples of the latest Nobel Prize. So could just, again, raise your hand. Could anybody here explain how the CRISPR-Cas9 system works? Yeah, 1, 2, 3, 4, okay. There are some biologists. Well, we heard just talk about Spain, but the Physiology and Medicine Prize, Nobel Prize in 2021 was about the receptors for temperature and touch. Does anybody here know how, could explain something about this? No? And well, the third one, our cells adapt to oxygen variability? No, that's all biology. Simple biology. Well, they got yes, one. Thank you. That's biology. But you see that even those who are biologists, those who are medical doctors, those of you who know some science, you don't know how to explain this, and that's not normal. But very often, you will be asked by journalists to explain, because you are the science guy. And so they come to you and they ask you, well, could you explain me? And so should you answer? Well, my answer is yes or no, it depends. If you have time to read, and that's what he did. That's what he does. Bill Nye has a good reputation because he's very well documented. So if you accept to talk about a topic, you have to do your homework. You have to know the science. And that's, yes, that's my third point. That's very important to know very well, to know the science. And if you can tell the journalist you don't know everything, but you can give an outlook, give the context. And as you studied science, as you had learned some science, you can read, and then you can explain at least a part for simple, or if you have more time, you can elaborate. But that's something really important. And well, I would add something. I wouldn't have said this perhaps 3 years ago, but now with the COVID, we had, I don't know in Moldova or other countries, but there have been a lot of people talking about the COVID pandemic, the COVID virus, and what should be done or not done, etc. And a lot of these people were not specialists, and they said a lot of garbage. So please, for the sake of science, don't talk about something you don't know about. You can be a medical doctor, but if you're not a specialist of viruses, a specialist of infectious illness, if you're a surgeon or an orthopedist, well, do your homework. You can then talk, but if not, please don't talk, because it can have great consequences. Okay, here I come to my fourth point, and again with a video a bit longer than the previous one. So listen carefully, please.
I'd like to tell you a story. It's a mystery of sorts, and it's about space, but it's not science fiction. This is a story about you, and the planet, and the sun, and the galaxy, everything in the universe. You see, all that stuff I mentioned is made of little pieces of what's called matter. About 14 billion years ago, all the matter that would later become you and me and the galaxy was all smushed together in a ball. Then the Big Bang happened and everything flew apart, particles started combining and made stars that exploded and made all kinds of other stuff that eventually became planets and people. Now, that's a pretty cool story, right? But as it turns out, it's really only a small fraction of the whole picture. You see, all that stuff, planets, stars, black holes, that's what's called regular matter. And it makes up just 1/6 of all the matter in the universe. The remainder is what we call dark matter. We call it dark because it doesn't interact with light, and we call it matter because it has mass. This is where the pie chart comes in. That little bit of light orange stuff represents the regular matter that makes you and me and the planet. And all that dark stuff is the dark matter about which we know almost nothing. So, what is it? Well, when we look at the way stuff moves around in space, we find we can't explain the motion if we only consider the stuff we can see. Spinning galaxies like the Milky Way are a great example of this. Most galaxies spin way too fast, and so far the best way we can explain this is that there's a lot more stuff in the galaxy than just what we can see, which provides extra gravity and allows them to spin faster without parts being flung off into space. It's like spinning a ball around on a string. If you go too fast, you expect it to break apart, unless the string can provide enough tension. The dark matter literally holds galaxies together, and we have no idea what it is. This is the part of the story we don't know. So, we're surrounded by this stuff. Right now, it's passing right through us, like some kind of cosmic ghost, and we can't see or feel it. How do you detect something like that? Well, a lot of people believe dark matter is made of these little particles called axions, which under specific conditions convert into photons, which are particles of light that we happen to be pretty great at detecting. So I'm trying to detect dark matter with what's called organ experiment. The idea is that axion dark matter comes into our detector and then converts into these tiny flashes of light that we can try and see. Now, it's extremely challenging to do these experiments for a couple of reasons. Firstly, the signals we're looking for are just unbelievably small. And secondly, there's so much we don't know about the dark matter. We need lots of different experiments looking for dark matter with different characteristics. And organ is designed to detect a really promising kind of dark matter that has never been searched for before. So hopefully by now, you're convinced that searching for dark matter is important. But if you're not, take a look at the pie chart and think about everything humans have accomplished with just that tiny fraction of matter we understand. Computers, medicine, spaceships. And imagine what we could do if if we unlocked the rest of the story. Thank you.
Okay, so it was a bit long. Well, it was not so long. It was only 3 minutes. It's from a competition. 3 minutes. 3 minute thesis. This one is from Australia. So, what do you think of this presentation? Was it good? Raise your hand if you think it was good. Yeah, you give it a good mark. I don't know if you won any prize at this competition. So if we come back, who is the audience? The audience is a jury with scientists, but not in his field, apparently. So his purpose is to win a competition. Does he know the science? Obviously, it's okay. And what can you say about this video that we didn't already talk about? What does it do? What did you see that we didn't already talk about? Do you have any ideas? Yeah, it simplifies the concept. Yes, that's true. Yeah, it makes it understandable. Yeah, but other? Yeah, sure. Don't please here. Yeah, gesticulates. He has body language. He has a strong body language. Yeah, that's true. Please. He started from the Big Bang. So, yeah, and so that's what I wanted to come. Well, here he tells a story from the Big Bang to us, and then to the future. Because at the end, he tells us, "Well, look what we could do if we had the solutions or the answers." So that's my fourth point. Not to tell a story. Don't just put the facts here, but try to tell a story with in mind your audience, your purpose, of course the science, and then you tell a story. I could add here, he made also a lot of comparisons with things we could have use of. Okay, and just to end, another short video. You know, I try to keep you alive this afternoon. So perhaps some of you already know this, but just for 1-2 minutes, I will tell you when to stop. A bit of music. So listen carefully.
There's a collider under Geneva, reaching new energies that we've never achieved before. Finally, we can see with this machine a brand new data peak 125 GeV. See how gluons and vector bosons fuse. Muons and gamma rays emerge from something new. There's a collider under Geneva, making one particle that we've never seen before. So, a complex scalar elusive boson escape detection by the Lepton telestron. The complex scalar, what is its purpose? It's got me thinking we could have had a more.
Okay, I think we can stop here. Yeah, it goes on for a few minutes. So, what do you think? It's what? What did you say? Yeah. No problem. But what do you think of this video? Do you think it's nice? Infotainment. Yeah. But did you understood what he said? Well, the words, but you understood the concept? Here we have specialists because you're near ICTP and you have friends who are physicists. You know, this video has been produced 10 years ago at the occasion of the discovery of the Higgs boson at CERN. So this guy, I think he's from Canada, and he was a student at the time. And well, it's a lot of work, good music, etc., etc. But what do you think about the words he used? If you don't know about the X, did you understood something? Not much. It's as a matter of fact, YouTube enables you to have the subtitles, and if you want to watch it again, but I'm not sure even with the subtitles you will understand much, because it talks about GeV. Do you know what, as a biologist, you're not supposed really to know what is a GeV? Yeah, giga electron volt. Yeah, that's physicist language, and LEP and tevatrons, these are big machines for physicists. So this video has been a hit among physicists. 10 years ago, with the discovery of the Higgs, all physicists were sharing this and saying, wow, that's fantastic, that's art without science, etc. But as a matter of fact, it's a very poor way of reaching out to the general public, and even other scientists. Well, I can tell you, this guy is the same guy, he did videos in biology also, and so perhaps for you it would be more interesting. But so that's only so that's good, he did that. I don't, but my fifth point is just know to mind your language. So it goes with the four previous one, of course, but be choosy of your words. And the last point is, well, I had a sixth one because someone chose me. Keep the limit of the time. Thank you so much.
Do you know what he does now?
No, I don't know. During a few years, he produced other videos, but most probably he had to work for a living.
Any question?
I'm still here tomorrow, so if you want to engage with me, no problem.
Thank you very much for your nice presentation. We need to move on with the next presentation. It will be presented by Dr. Felix Moron-Tabarrios from ICGEB, and his talk would be communicating the safe and effective use of biotechnology. Please,
Okay, thank you very much, Miro, for your kind presentation, and thank you everyone for your attention. So I have changed a little bit the title of my talk, because now it is more accurate to talk about communicating the safe and effective use of agricultural biotechnologies. What a wonderful welcome I had yesterday arriving here to Moldova. This was my first contact with this amazing country. I tested the mamaliga. This is a traditional dish that is made with yellow maize, you know. And well, I take this opportunity to ask you: have you ever wondered the origin of this maize for doing the mamaliga? I mean, yeah, from a farm, of course, but from the evolutive point of view, from the evolution, where this maize came from. Great, exactly, and how we arrived to our modern maize. So in Mexico, somewhere in Central America, actually, this is the wild relative of the maize, but we know the maize like this. There have been several steps of modification, of improvement, let's say improvements of the maize, no? By domestication, hybridization, and so on. So the modern maize is nothing like its original wild version. And this is not particular for the maize, also for animal farms from the animals, and almost all our food. Here are only 4 examples, but almost every vegetable that you can imagine, their wild original relative is a different organism completely. So this is for you to take this into consideration. Then, at the beginning of the 20th century, apart from the crossing, no, as all the farmers in the history have improved our food, there were additional techniques, no, biotechnological or technical techniques for improving the vegetables, our food. For instance, mutagenesis, using chemicals, or actually radiation, or another techniques that like protoplast fusion. And the importance of this is that the genetic diversity of our genetic resources for food are key for the survival, adaptability, and of course the use of the plant species. And then in the mid of the century, of course, Gregor Mendel was in the 20th century, but his work was vital for them understanding the inheritance mechanism. And I strongly suggest you to then look at the biography of this guy, Norman Borlaug. He is the father of the Green Revolution. Thanks to him, we eat bread and pasta and spaghetti nowadays. And he won the Nobel Prize for Peace because of his work improving the wheat. And of course, with the elucidation of the structure of the DNA and the nucleic acid, this eventually opened the door for what we know now as a genetically modified organism. This year, we are witnessing 27 years of safe consumption of GMOs. And safe consumption of GMO, and this is the genetic modification that are used for obtaining the GMOs, is just another step in the evolution of the plant breeding. We are adding more techniques as we gain more knowledge on the agricultural biotechnology. And now that we have already improved crops using genome editing techniques, the list of techniques that agronomists have at their disposal are enormous, and this is still increasing the tool and techniques that are available for improving our food and, of course, increasing the plant diversity. And in all these years of safe consumption of GMOs, it has been determined, the evidence showed that there has been, in those countries that have implemented the agricultural biotechnology, the GMOs, a reduction, they are reporting a reduction of the pesticide use, increase the yields of different crops, and also increase the farmer incomes. So one of the challenges is how to effectively communicate this. So I will take the lead from the previous talk from Luke, and I have prepared 5 recommendations that we apply for the agricultural biotechnology, but each of you could adapt it to your respective research. Again, you need to know your audience, of course. Who are you talking? You need to know, or even in an ideal world, you need to know what they think, how they feel, what are their communication needs, what channels of communication they use and prefer. And then it is important to go from a knowledge deficit model to a dialogue model for public engagement. I mean with this that a deficit model was used during decades, and this established that the people doesn't know. The people is stupid. They need information, so provide facts to the people. And this is not right. So now we need to promote that dialogue model when it is a two-way communication. So the deficit model, please don't use it. We all are intelligent and smart. That's it. We are equal. If we have a title from the university, that doesn't mean that we are smart. Absolutely not. For instance, the best practices, what not to do when communicating science. Well, you see here the list. I highlight not to use abbreviation as GE for referring to, I don't know, genome editing or genetic engineering or nothing. Of course, not use a complex language or acronyms, jargons. Instead, share analogies, metaphor, visuals, and remember, as Luke said before, that you all are the scientist guy. For instance, analogies. I would like for you to read each of these examples that I like so much, because, and you can see in this couple of analogies that jargon is not used. There are no use acronyms except for the DNA, of course. That is something that is already in our vocabulary of everyone. But they are, according to my thoughts, a beautiful example of analogies explaining what is the DNA and why it is important and the function of the DNA. Regarding metaphors and visuals, for instance, if our core message is saying, if we want to communicate that the white color of rice is defining trait, so we could use metaphors, like that, and at the same time visuals with a color code for explaining what means being a transgenic organism or a mutation that is based in an insertion, substitution, or even a deletion. So you can see there the difference between each of the examples in using metaphors and also visuals. It's so simple and so beautiful. The 3 point is the frame. This is, in the case of agricultural biotechnology, is precaution or innovation focus. I mean with this that we have the same concept, but under 2 points of view. The people that are more focused on the precaution, that are more in a precautionary mode, for instance, in these 2 examples, a group of people that say new technologies are dangerous because scientists tend to overestimate their ability to understand and control reality. And the same message, but with a frame of progress, focus on innovation. Every new technology is another chapter in the history of progress that elevates us further from the hardships of living in natural conditions. And I have brought 3 other examples of the same message, but framed in a precaution or innovation focus. And what I would like for you to take now is again, with another analogy of the structure of the protein. We have the primary structure, that's the sequences of amino acids, then the secondary, tertiary, and quaternary structure of the protein. If we compare this, if we make the analogy with a science communication text, this will be the words and not amino acids, the style, the narrative, and the frame. And for an effective science communication, it is important to go the other way round, starting from the frame. This is, for instance, with examples that I provided in the other slides. If we know our audience already, we know what we want to communicate. I mean, the core message. Now, let's frame that message in a way that it is adapted to our audience. And I think that, honestly, this is the part that I like the most, it is important to address or to tailor the message according to the identity and values of your audience. For instance, this is a typical advertisement of organizations that are against the GMOs, that are against the biotechnology applied to the agriculture, and the opposite, the typical kind of annonces or advertisement of organizations that are pro GMOs and pro-technology. They seem completely separate apart, but if you study well their discourses, the narrative, you can identify, even in these two polarized groups, shared values. For instance, in this example, we have identified that nature, solidarity, and choice are used by each of these groups to communicate their messages. We as a scientists, we could, or we should, to identify values in our audience and try to connect with those values. Please read these two examples of the same message communicated in two different ways. 10 seconds. Which one do you want that is correct? Which one? Yes, the second. But how many times myself I have made that mistake of saying this? No, that's not true. No, that's not true. You are not right. No, I read a paper that said the contrary. No, that's a fail. Absolutely not. As a science communicators, we should connect with the people, with their values, and with their identity. So the second example is something similar to what science communicators are pursuing. Let's go with a couple of other examples of the value-based messaging. We have, again, a core message that we want to communicate. Our regulatory system is based on sound scientific research. This is a fact. Of course, we have our target audience, let's say mothers, it's just an example. And what are the values of this audience? Well, mothers, their values are about family, safety, health, intuition. So how can we morph the core message in a value-based message? Something like that would work. Moms have a sixth sense that it comes to protecting their children. And that's why our moms sleep peacefully, knowing that nothing gets approved in our office without rigorous scientific evidence. The same message, but connected deeply in the heart of your audience. A different example. Our core message this time is gene editing is safe and beneficial technology. Okay, that's something, enter here and at the same time exit in this part. But let's say that we want to communicate this for the rural citizens of Moldova. No? What could be their values? Okay, tradition, conservationism, independence, dependability. So a value-based message could seem something like this. Our fathers and grandfathers overcame to farm this land and made it fruitful. We take pride in maintaining that legacy. Thanks to these improved crop varieties, we are ensuring that Moldavian agriculture succeed in a global economy. And we will continue to compete for generations to come. We think great-granddad would be very proud. So we are connecting with the values of our audience. This kind of message will remain in their minds, not the core message that is called. And finally, to keep in mind always the communication framework. This is having the goal of your communication, knowing your audience. We have talked about it, the message, I have talked about it, and the platform, where to communicate this. And for explaining this framework, I have brought a specific example that we have done in my group, Regulatory Science Group from the ICGEB. It was about the sharing biosafety communication strategy that we made in collaboration with the UN Convention on Biological Diversity. So here it is the communication framework that I'm proposing, and you will identify with the color code each of the stage. No? So we had in mind our goal, our communication goal. We were to, we wanted to raise awareness and increase the use of an international online platform that is called Biosafety Clearing House of the UN Convention on Biological Diversity. This is a huge word that is in place, but it's underused because many governmental officials are not aware or they don't know how to use it. So we needed to know our audience, so we performed a communication need assessment to determine the knowledge gaps in our audience and the communication attitudes, practices, and needs of the BCH, the Biosafety Clearinghouse, stakeholders. And based on the result of the need assessment, we designed a core message that then were tailored to each of the stakeholder categories, and then also based in the need assessment, select the social media channels and the branded hashtag, that is hashtag sharing biosafety. And this is an example of the visual that we developed that were addressed to each of the stakeholder groups. We have used a color code for each of the group of the images. And this is an example of the kind of messages that we developed together with this UN agency. And we have posted all these social media kit in a Trello board, and it is available for all the BCH stakeholders use it and communicate the message that we have designed in social media. So this is summarizing my presentation, that modern and emerging plant biotechnology are allies for strengthening food security, and sound and honest science communication is key for improving public acceptance of plant biotech products. And the key for successful science communication is know where your audience. We are insisting in that. It's important to pass from the knowledge deficit model to a dialogue model. And the messaging frame is key. For instance, precaution versus innovation mode, focus, sorry. And please remember always the messages that are based on the identity and values of your audience, and those arrows explaining the communication frameworks. Thank you.
Thank you, Felix. So, any questions from the audience?
No? Okay.
Thank you very much for what you reported about and sounds really interesting, and I'm wondering whether you communicate with the universities, because actually what they do is the modern direction in Europe and in the USA in education service program. Have you heard about it?
Not really.
Yeah, this is also kind of knowledge transfer between people from the science or from the university, from the society, the university, the students, to know some interesting scientific facts which are helpful for all people, for citizens who cannot deal directly with science and do not understand it. And this is a kind of service learning, and this is very popular nowadays. In the training and study, in the kind of education system. And what you are doing, this is also kind of service learning, transfer of knowledge. I think it would be very interesting to cooperate with the universities if students would also have some PhD students from the universities to tell people about the genetic and molecular biology background, physiological background of what we do, and if you could share the knowledge with them, how to do this transfer.
Yeah. Absolutely, I completely agree with you. I will be happy to be engaged in those kind of search of collaboration with the university, absolutely. Because I know that it is so much needed and so much important. Yeah. In our case, this example was more addressed to regulators and policymakers, but of course for non-specialist public, it is so much needed. Yeah. Thank you. Yeah.
Okay, so let's go further. The last the last speaker in this session would be Susan Kebalčić. I hope that I pronounced it correctly. At least in Slovenian would be like that way. So the address of her talk would be Science in the City, a public engagement toolkit. Please.
Thank you. Thank you very much. I'm delighted to be here and to see the fruits of our collaboration. Thank you to Professor Gropa and Dr. Porcescu and his team. And I'm responsible for the communications at the International Center for Genetic Engineering and Biotechnology. So I'd like to give you a very quick overview of what we do. But I would like to start. I'm sorry, how do I move it forward? Thank you. So it's the same. Thank you. I would like to start by transmitting a message that I heard at the Science Festival in Trieste last week, where there were hundreds of people present, university students, members of the public, and one of the talks involved the Nobel Prize winner, Aaron Chekhanova from Israel. And he said something that really reached me as a non-scientist. And I think that it's very useful and it's what we try to do. So science is a part of society, not apart from society. And so what we focus on is the importance of language and scientists reaching the general public and being part of that society. So these are our instruments of action at the ICGEB in order to get that message across to people. And why do we do that? Because we can affect science and policy through communication tools and practices. So as mentioned earlier today, as some of you called out, we do this for a series of reasons, because the audience is vast and because the more people you reach, the more effective your science can also be. So we do these through 4 main channels of activities, and those in blue are those that I'm going to focus on today as I talk through our public engagement model, Science and the City, which started in 2013, and we're now at our 7th edition. So it starts with our website and giving a coherent visibility to what we do. So Science in the City brings, a public engagement model brings science to the people of the city in the local vernacular or in English to reach a broader audience. We collaborate with the national television and with the radio. We have interviews. Basically, it's a panel meeting with scientific experts, generally a principal investigator from the ICGEB, together with experts from other fields. And so this body of work has been built up over the years with different funding agencies, and we're currently doing the edition, Science in the City, Italy, the first national edition, which has been funded by the Ministry of Research. So we're going through many different cities in Italy. For example, last week in Trieste at the festival I mentioned earlier, we had international speakers from the UK, together with Dr. Lawrence Banks and our former DG, Mauro Giacca, talking about viruses, friends or foes. And the special guest, Dr. Chris Smith, is also known as the naked scientist. So he's a clinical virologist. He's been working in the front line for COVID for the past few years. He's at the University of Cambridge. But in 1999, he established a radio show, a podcast. And we were able to get him to Trieste, and effectively he then did his own podcast from there, and will reach 500,000 people through his podcast next week. So engaging scientists and bringing experts from other fields together, you really do reach an infinite number of people. And the main thing is to communicate in a clear, coherent way. We were asked earlier who could explain CRISPR-Cas9. Now, my background is humanities, but because last week we had an event called Future Cures Are in Our Genes, with 2 speakers, one from ICGEB Trieste, Andres Muro, who heads the mouse molecular genetics laboratory, and Anna Cerezetto from the University of Trento. They actually described this genome editing procedure, and it enabled me to understand what it actually involves. And also I found it extremely captivating. So that's the goal. We've also used sports representatives or people from industry. So you partner these people on a stage and you give them 10 minutes each to discuss their point of view on a given topic. You have a captivating graphic, you have a captivating title, and you pull in the people. So we also did 10 events at the University of Trieste in streaming and then subsequently on podcast. We used new novel methods to engage with young people, including a virtual artist who actually designed the cartoon of the events as they were taking place, and then these were printed out and given to the people in the audience. We also had interactive surveys that posing a question on the topic during the actual event. And these then remain as podcasts on our channels, and you're able to reach thousands of people and build up a body of work that is also reflects the integrity of your research. So this particular project also involved a citizen science element that actually went on to win the EU Health Award for science communication. And so people were delighted with this, with the collaboration with the University of Trieste and ICGEB. It doesn't seem like a lot of money, 30,000 euro, but for outreach it's actually not bad. So our engagement activities are also carried over on the international arena with our colleagues in ICGEB Cape Town, who will be talking to you tomorrow, where two international Science in the City events have also already been held, one on misinformation and on the infodemic. So I'm sure you'll find that very interesting. This was the event in Cape Town. Engagement activities like this have also enabled us to be here today, thanks to our partnering with Moldova, and other projects that we then lead to, not only science communication projects, but projects of networking. And the TBFVNet project, which you'll hear about tomorrow from our colleague Alessandro Marcello, who's the group leader of molecular virology, we're actually heading the communications side of that project, which is funded by the Norway Fund. So we set up a website. Again, we set up a graphic that would captivate people. We send out a newsletter. So across these instruments of action, we broaden our membership and also our audience for the members. So you can see there that the latest news item is in fact that Moldova is now partner of that project. So we use multimedia also to imbue a culture of storytelling, which is another aspect that's been discussed today. And one of our projects involved making videos for how to explain very briefly and very quickly how basic research can lead to actually affect sustainable development and work towards that. And partnering with other festivals or with other municipalities have actually given us more of a stage to bring our efforts to. And I hope that this will play. Yeah. It's just the trailer.
In 2050, there will be 10 billion people, and we will have to produce about 60% more food than at present.
At first, I was very skeptical that we would succeed in a short time to give a precise answer.
As with every research project, Erase was and is full of difficulties.
Because all people should have access to medicines of good quality, and because access to medicine
is a fundamental human right. So I've passed the video on to our IT communicators here, so perhaps we can show it tomorrow or at another point. So a Science in the City toolkit involves all of these elements: graphics, language, local vernacular, keeping your language simple. But it also involves a lot of logistics, and that's where science communication can come in and make a bridge between scientists and society and work together to present events that actually reach a captive audience through all of these processes. And making things simple takes a lot more effort than making things complex. That was the final message from the Nobel laureate, and I think that that's something that we can keep in mind. Thank you very much for your attention.
Thank you, Suzanne, for your presentation. Very interesting. Any questions?
Yeah. So you've been a communication expert. Nowadays, because of so many fake news misinformation, what do you think is we should focus more on information or fighting misinformation?
Oh, information. You know, if you know about your topic.
Yeah, but it's like if you go to Facebook and you speak to people that don't have any science background, it's like
it's a waste of time. They won't change their minds.
How do we change that?
You combat that by putting out in parallel the truth of science. You know, you have the integrity, you build your integrity because you are a scientist. You have the expertise in a given field. You have undertaken studies in a national university. You have collaborations on an international level. You know what you're talking about. And so people will buy into that. People who don't, you know, it's very difficult to convince them. And I personally, I never engage in the debate. It would be great because everybody has their expertise, but we have limited resources. Our communications office was established 5 years ago. We didn't even have a communications office before that. We always had a website and social media since 2011, and we've just built up our activities since then, but always with a very limited, we didn't even have a budget when we started, but just formalizing that, and it's actually a really small budget, but we've been able to really make a big impact. We have about 100,000 people that we reach on social media. We have 1,200,000 audience on our website. We have a newsletter, an e-newsletter with a readership of 30,000. And these are all results that we've been able to build up through our activities with our partners and with our member states. So it takes time, but as I say, if you're consistent in your branding and in the look of what you do and the reference of what you do, it works. I hope. Thank you. Thank you.
I have one remark, if you mind. It was very nice what we hear from you to abstain from commenting, let's say, on the comments on the Facebook. I think that we get very, very tough lesson during this epidemic. And what our colleague from France also told us, it is very hard. If you're a medical doctor, you're still not qualified to comment on all medical things. We all know if we think with enough humility that we are happy if we really can very argumentative stand by the field we are working on. I have been questioned many times from, maybe I say lay people, but educated people, and say, how is it possible? In Slovenia we have a group of doctors who was opposing to vaccination, having really spread theories and opposing to any measures which are valid, and it was really hard. It was really unbelievably hard and immediately if you start fighting, you're losing the ground. The only thing which in Slovenia was well received is that some of the real closely familiar with virology and immunology people expose themselves and actually comment with real facts and also making arguments. One of them, my colleague, is a professor of immunology from our institute. I was just wondering how can he find time, because this is very time demanding, especially if you look through all of the points which our lectures today are very specific. One need to take into account, because it's not that you just paste something from scientific article. You need to make it that way that most of the people would understand. So they publish the many answers to burning questions, like on medical chamber webpage and so on. We are, including me, going to TV station in the late hour after the whole day of professional work, because we know if you don't go there, there will be other people with really less qualification, and they would actually provide misinformation to the public. It was really, really very challenging. But I'm really glad to hear about the podcast from the ICGEB, because maybe some of you look. I'm very happy to hear from you this, and very thankful to the scientists who find during this epidemic time. One of them from Germany have very good podcast, and it was nice combination because some radio station come into play, but it was unfortunately only in German. So it would be very nice to translate it or make it in English to be more available. And some of them, let's see, maybe on Twitter, which is also full of garbage, but there are some very known professionals, like probably you heard about Eric Topol. He's still serving very accurate, very short and argumentative explanations. So I think it's our duty as a scientist really to step in. I told you really many times we are exhausted of everything, but we still go at very late hour to the television, or they usually try to have you live. So you need to be there at 10 p.m. and people don't understand. Doesn't matter. I mean, you are not paid for that in any way, except that you have a good feeling to provide right information. And I was really happy when I get feedback from the lay people to my presence in the media and said, please come more often, because you really have very simple language so people can understand, and not talking about a lot of theory and what could happen or will happen. And yes, I think this is one of the duties as we as a scientist or teachers are bound to provide, and to give support to other colleagues maybe who are also exposed. So really thank you for your talk. With this, I would conclude our session, but I would give the final word to Professor Gropa, which have a couple of announcements to make. Here. Okay.
Dear colleagues, it's finished our first day of the work. Thank you very much for all that was done today. Thank you very much for all the speakers. And I want to communicate to you that tomorrow morning we will start our work in 9 o'clock, and I want to ask all of you to be in 9 o'clock in this place and to start our work, because tomorrow it's a very interesting day. It's a lot of actual and important presentation. Chair for the first our meeting will be Professor Olga Tagadiuk and Dr. Andrei Kichuk, and I want to ask you to be all of this time here. Thank you very much for all of you, and I want to ask our guest to come now in front of our building, and perhaps will be our cultural program. Vă mulțumesc mult și vă așteptăm mâine la orele 9 pe toți pentru a continua lucrul. Vă rugăm foarte mult să luați aminte, să nu întârziem și să fim cu toții prezenți. Vă doresc o seară liniștită. Îl rog pe domnul profesor Ceban să se apropie de la Departamentul de Igienă. Mulțumesc!